the very beginning, there was a singularity, alone in the vacuum of space. A ball of infinite mass and gravity, so strong that even light could not escape it. Then suddenly, the singularity became unstable and exploded, sending an array of energy into the vacuum of space. Eventually, most of the energy cooled down and became matter. Eventually, these new particles of matter began to form clouds of particles, which eventually collapsed to form galaxies. Within these galaxies were smaller clouds of particles. One such cloud of particles within our own Milky Way galaxy was the beginning of our solar system. Particles, like all things with mass, are attracted to other things with mass due to gravity. Gravity is the attraction between one thing with mass to another thing with mass. It is known as the weak force in physics, despite the fact that it holds planets and the solar system together, because it is the weakest of the four fundamental forces of physics. But despite that, it is able to make dust particles move towards each other and stick together. As these dust particles stick together, they create a larger and larger object. As an object becomes larger, its gravitational force becomes stronger, and so it begins to pull in more and more particles at an ever-increasing rate. Eventually, there was enough particles, and therefore enough pressure, for the particles to begin a nuclear fusion reaction, and in doing so, a star was born. In our solar system, we call that star the Sun. The reason our Sun is so important in the creation of our planet is that it has been the strongest external factor in the creation of our planet since our planet first began. It is also important because without it, life simply cannot exist, and life itself has also played a massive part in the formation of our planet. In the same way that the Sun formed, many dust particles began to stick together under the force of gravity until they formed tiny rocks. Then these rocks began to stick together to form larger rocks. This process continued for millions of years until the embryonic Earth was formed, along with hundreds of other planets that spun around the Sun. These planets were so large compared to the rocks that were left floating around the solar system that they continued to pull in more and more rocks, and in doing so made themselves even larger. The larger they got, the more mass they had. The more mass they had, the more rocks they pulled into themselves, which in turn increased their mass and size. But this embryonic Earth was nothing like the Earth we see today. Rather than a beautiful green planet that is a haven for life, it was a molten hot rock above 2,000 degrees Fahrenheit. There was no air to breathe, just carbon dioxide, water vapor, and nitrogen. No life could have survived there. If you were placed on the surface, you would not be able to breathe, and you would be instantly vaporized by the intensity of the heat. There was no surface as such. The entire planet was a boiling ball of molten hot rock. A smaller planet called Theia was then pulled towards the Earth due to Earth being larger and therefore having a stronger gravitational pull. Theia was pulled towards Earth at a speed of around 15 kilometers per second, around 12 times faster than a bullet. The collision propelled trillions of tons of debris into space, but some of the mass of Theia was instantly bonded with Earth. Some of the debris was pulled back to Earth by Earth's gravity. The rest began to form a ring around Earth, and from this ring a ball was formed, which eventually became our moon. However, this embryonic moon was much closer to Earth than the moon is today. This embryonic moon was only 22,000 kilometers away, as opposed to the moon today, which is 384,000 kilometers away. The Earth began to cool, and solid rock began to appear on the surface, surrounded by a sea of molten hot rock. The Earth was spinning so fast that a day lasted only 7 hours. Several 100 million years later, the Earth had cooled to the extent that there were much larger areas of hardened rock on the surface. 3.9 billion years ago, Earth was hit by a massive stream of meteors. These meteors were composed of rock, but also small amounts of water. So as they smashed into Earth, they deposited water on the planet. Over the next 25 million years, they deposited enough water to one day form the oceans of our planet. Many water-carrying asteroids smashed into Earth before this time, but the water was not able to collect, as the surface at that time was so hot that water simply vaporized and was lost into space. So Earth had water, but life would have struggled to survive, because the Earth's rotation, although slowing, was still much faster than today, causing gigantic storms that make the storms of today seem like nothing in comparison. Add to that the fact that the moon was still much closer than it is today, so it caused massive tides that washed across the ocean of the planet. Our moon still dictates the water around our planet today. This is what creates our tides. The closer an object is, the stronger its gravitational pull, which is why its pull was so much stronger and therefore created these massively destructive tides. Eventually, the moon began to move away from Earth and head towards its current orbit, making Earth's oceans relatively calm. The Earth's spin also began to slow down, which also helped the water and the climate of Earth to calm down. Then small islands began to appear above the surface of the water, caused by molten hot lava pouring onto the surface of the planet to form volcanoes. Eventually, this molten hot lava began to cool and eventually produced volcanic islands. Eventually, these islands would become so numerous that they would join together to form the first continents of our planet. With the land and the water, Earth was beginning to look a little as it does today. The only thing missing was the green which is the process by which cells produce energy. So photosynthesis, which is the means by which plants produce energy in order for them to live, also just happens to produce oxygen that we require to live. We are fortunate that plant life exists, because if it did not, then we would not exist either. Over the next 2 billion years, oxygen levels continued to rise. At this stage, the Earth's spin had slowed to the extent that a day lasted around 17 hours. The Earth's surface, at this point, is now completely solid, except for the odd volcano erupting onto the surface. But the core, at this point, is still molten hot, as it is today. Because of the convection currents caused by the heat in the core, the Earth's surface cracked and created tectonic plates, which moved as the convection currents moved. So the surface of the planet moved and changed shape. This forced many of the continents together to make a supercontinent called Rodinia. This movement is still happening today because the Earth's core is still so hot, as its heat is insulated by the layers above. But the Earth still did not look like the Earth of today, as it was not as green as it is now. Because although life had started, it all resided within the oceans of the planets. The Earth looked like a giant desert planet, so it looked more like Mars than Earth. That's because there was no life on the surface of Earth until around 750 million years ago. Then the continent of Rodinia began to break apart, and thousands of massive volcanoes spilled onto the surface, pumping out sulfur, which went into the atmosphere and came down as acid rain. The acid rain exposed the underlying rock, which then absorbed most of the planet's carbon dioxide. Without carbon dioxide to trap the sun's heat, the planet began to cool, and after around 2,000 years, the planet's temperature dropped to around -60 degrees. This put the Earth into an ice age that is often referred to as Snowball Earth by scientists. It is the coldest, longest-lasting ice age ever to take hold of planet Earth. An ice age starts at the poles and works its way down towards the equator, because the poles are the coldest part of our planet. A wall of ice, thousands of feet high, spread from both poles and eventually met in the middle at the equator, leaving an ice sheet thousands of feet high around the entire planet. The reflective nature of ice resulted in virtually all of the sun's rays and heat being reflected back into space. The Earth became like a giant disco ball, reflecting nearly every energy particle that came towards it. Even the sun could not melt the ice. Earth could have remained a frozen ball forever. But fortunately, this ice age only lasted for 16 million years. It was the Earth's core and the volcanoes that came from it that rescued the planet. Throughout the entire ice age, volcanoes continued to erupt. But due to the sheet of ice that covered the entire planet being thousands of feet high, they simply could not break through. But eventually they did. And because the carbon dioxide absorbing rocks were covered in ice, they were not able to absorb the carbon dioxide. So now, with the planet's atmosphere once again being filled with carbon dioxide, the sun's rays began to get trapped in the atmosphere again, instead of just reflecting out into space. So with this warm blanket of carbon dioxide around the planet, the ice age began to melt. As the ice melted away, it exposed even more volcanoes to the atmosphere, resulting in more magma spewing onto the surface of the ice, which accelerated the process of the ice melting away. As the ice melted, it broke down hydrogen peroxide, which was formed by the sun's rays reacting with the ice. The breakdown of hydrogen peroxide released massive amounts of oxygen into the atmosphere. The Earth came out of its coma, and then things really started to change. At this point in time, an Earth day was around 22 hours long, as the planet's spin continued to slow. The temperature of the planet at this point was around 30 degrees centigrade. So now, with such an abundance of water and land, the planet had returned to a perfect place for life to survive and thrive. Fortunately, in the depths of the oceans, life survived. Because although the temperature drops the deeper you go underwater, in an ice age, at the bottom of the oceans, the heat from vents and underwater volcanoes was insulated by the ice, and so life survived and even thrived as it continued to evolve into the beginning of complex life. This leads to the Cambrian explosion. From 541 million years ago to 530 million years ago, which is the beginning of the Cambrian period, there was the largest emergence of different organisms than in the entire history of planet Earth. The massive increase in oxygen levels allowed creatures to grow larger, more complex, and even develop bony skeletons in order to produce more sophisticated movements. There was around 50,000 different species of plant and animal living in the ocean. Life had really started evolving and adapting at its fastest rate ever. 450 million years ago, a new continent was formed. The continent was called Gondwana. But still, there was no life on the surface of Earth, except for a few bacteria and a few patches of algae in the pools that formed inland. The reason for this is that the powerful rays of the sun obliterated the creatures on the surface of the planet, or caused them to die through denaturing their DNA so that they could not function, and also became cancerous. In the oceans, life is protected because the water filters out and absorbs much of the radiation that comes from the sun. However, at this time in the history of Earth, life had no protection on land. However, around 20 kilometers above the Earth's surface, the sun's rays slowly began to turn oxygen into a substance called ozone. Ozone is highly absorbent of the sun's rays, and it therefore begins to shelter the surface of Earth against the sun's rays. This allowed the small pools of algae on the surface to evolve into moss, which was then able to extract minerals and water from the rocky surface and begin to break it down into soil. The moss then pumped out even more oxygen, directly into the atmosphere, resulting in oxygen levels rising very high. Then, some of the ocean creatures began to use their fins to move out of the water on the odd occasion. And as they did this more and more often, their fins eventually evolved into legs. As they spent more time on land, they eventually became full-time land-dwelling animals. These creatures would eventually evolve into dinosaurs and mammals. At the same time, plant life was evolving also, with mosses and ferns growing everywhere. As plant life would die and become buried in soil and rock, it would get compressed, and in doing so, became coal seams that humans would eventually dig up and use as a power source in the Industrial Revolution. For the first time in Earth's history, the planet was starting to look quite green. It no longer looked like a watery Mars, as the green appearance of the land continued to deepen and deepen. One of the key developments in the history of plant life was the invention of the seed. Before the seed came along, plant life had to spread itself by spores. Spores are just singular cell organisms that, provided they land in plenty of water, can produce a plant itself as it divides and replicates. The seed was a game changer, however, because it can last for months and even years without water or food. This enables the plant life to spread itself much longer distances, because the spore would die after a few days, and you can only go so far in a few days. But the seed, lasting so long, could literally blow right across the continent and then produce a plant. This development spread plant life around the planet. This made the planet more green in appearance, and also massively increased the oxygen levels of the air, allowing animal life to flourish. From the beginning of its life, planet Earth has been transformed from a molten hot ball of rock in space to a beautiful green and blue planet teeming with the variety of life. In fact, the oxygen levels were so high that insects of this time were giants compared to the insects of today, because their respiratory system was so efficient in such good conditions. They were able to produce and process so much energy in order to grow. There were dragonflies the size of an eagle, centipedes 5 meters long, and spiders over 30 centimeters long, with scorpions the size of lambs. Eventually, a new type of creature would evolve into being: the reptile. These reptiles would grow into massive predatory beasts, far larger than the Komodo dragons, which are the largest lizards on Earth today. Their run, however, would be short-lived, as the entire continent suffered a flood basalt eruption, reducing much of the continent to a lava flow. A flood basalt eruption is when a massive plume of mantle rises up from deep inside the Earth and comes through the cracks in the Earth's crust. This is different to a volcano, as a volcano rises from one point and then the lava flows down the side of the volcano. With a flood basalt eruption, the entire landscape erupts, which means a creature has nowhere to run. They become trapped in an endless network of rivers of lava. This was the largest extinction in the history of planet Earth. It is called the Permian extinction. The flood basalt of the Permian extinction left half of the planet unharmed at first, but then the ash began to fall on the other half of the continent, around 16,000 kilometers away. The sulfur ash suffocated all the other creatures all around the world. As is the case with regular volcanoes, the basalt flood eruption released sulfur into the atmosphere, which mixed with water and then fell as acid rain. This intense acid rain burned everything it touched, including all the animals, resulting in their death. Yet again, what starts as a fairly local disaster becomes a global one. Further eruptions increased the atmosphere's carbon dioxide concentration, which increased the global temperature and caused a drought which killed nearly all the plant life. Any animal that had survived the actual eruptions, the ash, and even the acid rain would have found it nearly impossible to survive, as their food source ran out. But it was not just the life forms on land that were decimated by the Permian extinction. The acid rain will have massively shifted the pH or acidity of the oceans, which is always deadly to the vast majority of sea life. The hotter temperature caused by the increase in carbon dioxide resulted in the oceans losing so much of their oxygen that so many of the creatures of the oceans needed to respire. The result was a massive extinction of sea life. The increase in global temperature increased the temperature of the frozen methane gas that was in the ocean seabed, causing it to rise to the surface and into the atmosphere, which further increased the temperature of the planet to somewhere near 100 degrees. The Permian extinction wiped out nearly 90% of the species of the planet, with less than 5% of the animal kingdom surviving. The eruptions of the Permian extinction continued for nearly 500,000 years, with sulfur gases continuously pouring out into the atmosphere. The Earth changed color from blue and green back to a watery Mars-looking planet, a desert planet with water. 200 million years after the end of the Permian extinction, there was just one supercontinent called Pangaea. The planet had all but recovered, as it was now a ball of green and blue, and the acidity of the Permian extinction had dissipated. A new creature had evolved into existence, called the dinosaur. The dinosaurs evolved from reptiles that survived the Permian extinction. Like the reptile, some dinosaurs were herbivores, so they did not eat meat, but instead ate leaves and grass. An example of a herbivorous dinosaur would be the Diplodocus, which is one of the largest ever dinosaurs to live. The Diplodocus was 26 meters long and weighed 15,000 kilograms. An example of a lone predator dinosaur was the Tyrannosaurus rex, which weighed nearly 8 tons. The Tyrannosaurus rex is thought by many to be the greatest predator that ever lived. Dinosaurs dominated the Earth for around 165 million years, which is interesting when you think that humans have only been around for 300,000 years. We have been around for less than half of 1% of the time that the dinosaurs were around. It certainly puts our own superiority into perspective. During this time, there was also a massive increase in ocean life, and each time a sea life creature died without being eaten by a predator, it would fall to the bottom of the ocean because its body was more dense than the water that surrounded it. Eventually, sediment and rock would cover these dead animals and squish them into oil and gas. The earliest gas wells were drilled in China in 347 AD, and since then we have drilled for it more and more, as our dependency on fossil fuels has grown and grown as our population has increased. Of course, we are now moving towards renewable energy, as we are concerned that we humans are creating a climate change. However, the switch to renewable energy is slow, so we are still very much dependent on the marine life that died so long ago. We do not just use the oil for energy, we also use it for plastic, a substance that is used in nearly every product we make. It is at the heart of everything we do, as it surrounds us constantly. The good thing about plastic is it lasts almost forever. The bad thing about plastic is that it lasts almost forever. So we have no choice but to open up the earth and fill it with plastic, and in doing so change the content of Earth's surface. More worryingly, however, is the plastic that ends up in the sea and ends up being ingested by fish, which we eventually eat, resulting in micro beads of plastic entering our bodies. Eventually, the continent of Pangaea began to move apart and split off into many pieces as the planet moved towards the way it looks today. So the dinosaurs continued to evolve as Earth changed slowly over time due to the tectonic shifts of the Earth's crust. It seemed like they would dominate the planet forever, but then one day that all changed. A meteorite the size of Mount Everest came crashing down to Earth. Half of it landed on land, and the other half crashed into the ocean near what is now Mexico. As a consequence of it partly landing in the ocean, it produced a tsunami nearly 1 mile high that reached nearly halfway across the planet. Even dinosaurs living 100 miles inland would have been killed by this massive, fast-moving body of water. The tsunami was devastating, but nothing compared to the destruction caused by the part of the asteroid that landed on land. Any dinosaur living near the blast site would have been killed instantly. Scientists have suggested that the explosion of the impact would have been the equivalent of 10 billion nuclear bombs. This means that even if you were 100 miles away, the blast wave would have burnt you alive. In fact, the crater from the asteroid strike is estimated to be 180 kilometers wide. The debris would have risen into the atmosphere, with much of it coming back to Earth as meteors, setting fire to other parts of the planet. The force of the impact created an earthquake that lasted for weeks. And as if all of this is not bad enough, the main killer was the smoke and the dust that was caused by the explosion. The smoke and the dust blocked out the sun's rays and put the Earth into another ice age. Plants withered and died without sunlight, which meant that the herbivores died, and that resulted in the predators dying also, as they had nothing to feed on. 165 million years of dinosaurs ended almost in an instant. It is also worth noting that the asteroid was full of sulfur, which ended up high in the atmosphere. The sulfur then cooled and joined with water droplets in the atmosphere and came down as acid rain. The acid rain would have killed many of the land-based animals, just as it had in the Permian extinction, but its deadliest effect was on sea life. The acidity of the world's oceans shifted dramatically as the rain hit the oceans. This shift in acidity is said to have killed a huge percentage of the Earth's sea life. We humans have certainly had a large effect on the Earth, so it is worth noting that the effect of that asteroid was not just that it killed the dinosaurs and put the Earth into a permanent dark winter, but that it allowed the mammals to survive and thrive and led to us. There is no way the mammals that led to us could have taken hold of the planet if the gigantic predators were still roaming the Earth. The mammals were able to survive the asteroid by living underground away from the fires that raged across the planet. They were also able to survive because they could eat just about anything. This is particularly important because we ourselves are mammals. During the reign of the dinosaurs, it was difficult for the mammals to survive, let alone thrive, to the extent that they grew in size. During the dinosaur era, the majority of mammals weighed less than 1 kilogram, which means they were much smaller than the mammals of today, who on average weigh 7.5 kilograms. 46 million years ago, the Earth looked almost exactly as it does today. The spin of the Earth had slowed to around 23.5 hours in the day, and the planet looked like a very familiar ball of green and blue. However, the temperature at this point was more than 43 degrees Celsius warmer than today. Another difference between Earth then and Earth now is that India had not yet joined to Asia. India and Asia were originally separate continents, but due to the fact that they were on separate plates of the Earth's crust, and those plates were moving towards each other due to the convection currents of the liquid magma in the mantle of Earth, they moved ever closer to each other until eventually they met in the middle. Because the convection currents continued to push them together, the land began to buckle and therefore rose up to form the Himalayas, which stand at nearly 9,000 meters above sea level, with the highest peak being that of Mount Everest. Mount Everest reaches up into the jet stream, which is the altitude that jets and aeroplanes fly at. The Himalayas are in fact still rising. Walking on 2 legs is much more efficient than walking on 4. The apes began to evolve and began the first race of humans, Homo erectus, around 1.5 million years ago. Sensing that there was more moisture and therefore more water in the northerly directions, they began to migrate to the north. Homo erectus continued his journey and eventually evolved into the Homo sapiens around 250,000 years ago. And as sea levels dropped around 60,000 years ago, the Red Sea became shallow enough for these early humans to cross. These humans crossed the Red Sea and began to populate India, Asia, and then Europe. However, their migration was made more difficult when another ice age set in. So as the Homo sapiens traveled north, a wall of ice traveled south to meet them. This wall of ice, around 100 meters high, scraped at the landscape and changed it forever. Around 20,000 years ago, the ice sheets had stopped moving, but by then it had covered most of the northern hemisphere and was around 2 miles high. With such a gigantic amount of the Earth's water being stored within it, the sea levels of the planet dropped drastically, and as a result, a bridge of land appeared above the water, allowing humans to migrate from Siberia to Alaska, and in doing so, the population of the Americas began. This was the last great migration of mankind. Around 17,000 years ago, the ice sheets began to retreat, revealing an excavated northern hemisphere. The Great Lakes of Canada were carved from the ice. By 7,000 years ago, the ice had completely retreated to the north and south poles. Over the next 7,000 years, the human race would continue to evolve in terms of genetics, but also in terms of advancement in technology, changing the planet for good or bad. massively more than any other species ever has. We have extracted the gas, oil, and coal that was previously mentioned from deep within our planet. We have built bridges across the water. We have covered the planet in giant buildings that stretch up into the sky. We have also deforested the planet, and in doing so, have altered the planet's atmosphere. We have churned out carbon dioxide, and in doing so, increased the temperature of the planet, which has further increased the deforestation. We have also surrounded the planet with satellites all around the globe. One day, the planet may not look green at all. Of course, this has happened before, as previously mentioned during the Great Extinction events. The difference this time is that in the past, the extinction and deforestation of the planet has been down to the natural geological processes of the planet itself, not because of one species that is now growing in population at an ever-increasing rate. Our advancement was slow up until the Industrial Revolution, but since then, technology has advanced at an incredible rate. We have started to change our ways in order to help stave off the negative effects of our ever-increased population. But will that be enough when researchers have estimated that the population of Earth will be around 14 billion in 1,000 years' time? 1,000 years sounds like a long time. But when you think that the dinosaurs were around for 165 million years, it really is no time at all. The question is, will we rule the Earth as long as the dinosaurs did? Perhaps the Earth will save itself from us. Another global ice age would obviously, even with the technology that we have, reduce our numbers drastically. We see the effect we have had on Earth most clearly when we see Earth at night. Before us humans, the Earth looked almost completely black at night. But now it is littered with the lights of civilization. 1,000 years in the future, the Earth may be completely littered with lights at night. And perhaps during the day, it will look something more akin to a desert planet, as the deforestation of the planet will have moved so far that the green we see today will have been replaced by the sandy color that we already see in the desert areas of our planet today. The truth is, nobody knows for sure what Earth will look like in the future, because we have no idea as to whether or not we will survive, and we have no idea what geological processes could occur, whether from the planet itself or from outside in the reaches of space. But one thing is for sure, the Earth will continue to change before its inevitable death when our sun explodes and vaporizes it. The question is, will us humans be alive to see it?